You know those complex visual tools, the flowcharts, the pipeline builders, all those things where you drag nodes onto a canvas and connect them with arrows?
Yeah, these seem so intuitive when you're using them.
Exactly. But building one from the ground up is, well, it's an absolute technical maze. Today, we are taking a massive stack of source material from a multi-month experiment focused on doing just that, creating a node-based visual automation system called Nubo. We're specifically looking at its evolution toward the second iteration, N2, built on the Odoo OWL framework.
It's a journey that, it touches on pure mathematics, Python flexibility, and why sometimes you just have to throw out months of work.
That's the only way forward sometimes.
And that willingness to pivot is really the core lesson here. For you, the listener, this isn't just some Odoo case study. We are dissecting the universal challenges that rapid application developers face.
Right.
That intense friction between the features you want the user to have, the performance you need the app to deliver, and the foundational architecture you choose. It's that classic battle of build from scratch versus use a library, and we get to see the real-world fallout.
So let's start with the anatomy of this kind of tool. If you look at any node-based UI, whether it's for machine learning or just diagramming, what are the core components, the non-negotiables?
At their heart, they're actually elegantly simple, despite how complex they look. The source material breaks it down to three constants. First, you've got the canvas or workspace area. That's the stage.
Where the magic happens.
Exactly. Second, the node list. That's your toolbox of components, what the user can actually place on the canvas. And third, a menu or a toolbar for all the global stuff like saving, panning, zooming.
And the developer noted that most of the variations we see out there, like comparing a general tool like draw.io to a really specific chatbot builder, it all comes down to layout and, more importantly, the application's purpose.
Precisely. If you're building a specialized tool for, say, a customer service flow, you might only need a few types of nodes, maybe 2 connection points. The layout can be pretty rigid.
But the second you go general purpose, like an automation tool, your UI has to get way more complex to handle, well, anything.
Endless possibility.
And here's where the first critical trade-off of the entire Nuido project came up. The creator had this one seemingly simple desire for the UI. They wanted to see all the node parameters immediately when they opened a workflow.
No clicking required.
And clicking, no side panels, no modals, just boom, everything is visible.
Which sounds minor, but wow, that is a profound architectural decision. And frankly, a really challenging one.
Why is that so huge?
Because nodes suddenly can't be these neat little icons anymore. They have to be large, embedded forms with input fields, drop-downs, checkboxes, everything.
So you're sacrificing a huge amount of workspace real estate.
A dramatic amount. They basically prioritize parameter visibility over canvas capacity. And that decision had massive ripple effects.
And that one choice forced an immediate architectural demand. The developer was planning 2 different but related apps, an AI chat studio, which needed connections on labeled sections of a node, and the core Nuido Flow automation app, which just needed generic, unlabeled in and out ports.
So to avoid coding and maintaining 2 totally separate frameworks, they realized they needed a single, flexible base library. It had to support both of those styles, the specialized section-based connections and the generic port connections.
So right off the bat, they had to build a foundation that could handle 2 different visual languages at the same time.
Yep, which definitely complicates that build-from-scratch decision we're about to get into.
Speaking of which, here we are at that critical crossroads for any developer. Build it all custom or lean on established external libraries.
This choice was really heavily constrained by the environment. Nuido is built on Odoo, and Odoo uses its own component framework called OWL.
And all the good node libraries are for React or Vue.
Exactly. High-quality existing libraries are everywhere, but not for OWL. So the developer wasn't choosing between 2 easy paths.
It was 2 difficult paths.
Right.
Yeah.
Either try to meticulously integrate a complex, pure JavaScript library that wasn't designed for OWL, or just bite the bullet and build the entire dynamic UI from scratch.
And they chose from scratch.
They did. And the rationale, was initially rooted in just being inexperienced with these big node apps. The creator felt the general purpose libraries were just overkill, too much feature bloat for what they wanted.
But that choice immediately exposed them to the painful realities of UI physics.
It really did. And this brings us to the first monumental technical lesson from the source material: the importance of foundational math and geometry.
I mean, we're literally talking about basic high school geometry homework coming back to haunt a professional application developer.
Precisely. You don't need a PhD in applied math, but you absolutely have to know what these concepts are for and how to apply them. The sources mention the Pythagorean theorem, Bezier curves, and just general geometry over and over again for something as basic as drawing an arrowhead correctly.
Okay, let's illustrate this because this is where the theory becomes like practical pain. If you designed your node as a simple circle, calculating where an arrow hits the boundary is trivial.
Super trivial. It's always just the radius away from the center, no matter the angle. Simple high school math.
But because the developer chose those rectangular, feature-heavy nodes, the ones that are more like forms than blocks, the geometry instantly gets complicated.
Instantly. The distance from the center of that rectangle to its border is now variable. It depends entirely on the angle of the connecting line.
So if a line comes in flat, horizontally, the intersection point is easy. But if it comes in at a 45-degree angle, you need trigonometry to find the exact point where that line hits the bounding box.
Or else the arrowhead ends up floating slightly inside the node, or it's detached, and it just looks broken. It's tedious custom geometry. And without a solid grasp of those functions, implementing smooth Bezier curves or even just placing an arrowhead becomes a huge roadblock.
So lesson 1 is basically that node-based UIs are a direct application of graph theory.
They are fundamentally graph theory. You are defining vertices, which are the nodes, and edges, which are the connections. And that mathematical structure has to be respected for the UI to work.
That deep technical detour actually brings us right to lesson 2. Goals and detailed planning matter. Unless, as the creator admitted, the whole point is just to learn.
Right. They realized later that the AI Chat Studio, which was the whole reason for those complex section-based connection points, could actually be implemented within the main workflow app.
So the initial architectural complexity built to support 2 separate apps?
Suddenly became a bit less necessary. And that is such a classic development cycle moment. The scope changes mid-project, some of your early complex work becomes obsolete, but the time you spent on it is a sunk cost. It's a painful but valuable lesson about over-engineering.
Okay, so let's pivot to the back end now, the Python side. They had the same Scratch or library choice for the execution logic.
And again, the decision was Scratch. Python has visual programming libraries, but they were either tightly coupled to their own UIs or just way too comprehensive for the simple engine Odoo needed.
They wanted something lightweight that could leverage Odoo itself.
Exactly. And the strategy they chose was brilliantly simple for integration. Registry mapping with dynamic instantiation and dynamic function calls.
So what does that actually mean for you as a developer using it? How does that work in practice?
It means they didn't have to write tons of explicit conditional logic, like if node is type A, run function A. Instead, they just stored the node's type and the function name as strings in the JSON file.
Oh, clever.
Yeah. So when the workflow runs, the engine just looks up the right Python class using that string, that's the registry mapping, and then dynamically creates an instance of it and calls the function name that was also stored as a string.
So it's incredibly modular.
Totally.
Wow.
If Odoo already has a function to send an email or run a cron job, Odoo just needs to wrap that function, expose it as a node, and it can execute it just by listing its name in the JSON.
And this simple backbone let them quickly leverage Odoo's built-in features. Cron jobs became schedule triggers, custom controllers became webhook triggers.
And they successfully integrated external Python libraries too. Jinja for templating, GQL for GraphQL, and later, all the libraries needed for the AI workflows. The practical results were pretty impressive.
Yeah, they were getting automated emails, structured AI output, and even integrating with complex services like Shopify, all orchestrated on that visual canvas.
It really showed the power of keeping the core engine simple and just maximizing that integration flexibility.
Yeah.
But, and this is a big but, despite having a solid backend, the whole thing still needed a major overhaul for Odoo too.
Okay, we've arrived at the painful turning point. If the JSON and the Python registry were sound, why was N2 necessary? Why throw out months of that front-end work?
It came down to a fundamental limitation in that initial object-oriented front-end structure. And this is a huge lesson for state management in any complex app.
What was the problem? The original N1 version treated nodes as, what, traditional OOP classes?
Exactly, object-oriented programming classes with their own methods and internal state. Which seems intuitive when you're building UI components.
It does.
It is, until you realize you have to implement basic features like a robust undo and redo. To track history, you need to serialize the entire state of Canvas, the position, the parameters, the connections of every single node every time an action happens.
And why is that so hard with the OOP approach?
Because you're not just trying to serialize simple data. You're trying to serialize these complex living class instances that have methods and internal references. Turning all that into a plain data structure you can store in a history stack is it's cumbersome, it's error-prone, and as the developer put it, it felt forced and hard to manage.
So every time you want to save the state, you need custom logic for every single node type? What a headache.
It was an architectural dead end for delivering basic editor functionality.
So the N2 pivot was really a structural shift. They moved away from focusing on the node as this complex active object.
And moved toward focusing on the node as a simple, passive data schema.
They changed the core representation.
Precisely. And this is where a couple of external libraries they mentioned, Zod and Immer.js, become so important. Zod is used for schema validation. It defines exactly what the node's data should look like.
So if you define the data structure up front, serialization for history tracking becomes infinitely simpler. You're not saving a weird object. You're saving a guaranteed, validated data structure.
And Immer.js solves the next problem, which is state mutation. Immer lets you make changes to your state object as if you were changing it directly. But behind the scenes, it ensures the original state stays completely immutable.
Which is the holy grail for easy, robust undo and redo.
It is, because you always have a perfect, unchanged historical snapshot of the graph data to just revert back to. It was a trade-off, but it solved the state management crisis.
So that technical realization was one driver. The second, more visible reason for N2 was the direct result of that first big trade-off. The nodes were just too big.
Yeah, because they displayed all the parameters immediately.
This goes right back to that universal UX problem. If your user base is diverse, you can't optimize for size. People running complex workflows on small screens, their canvas just becomes unusable.
Pan and zoom can only do so much when every single node takes up a huge amount of visual space.
The solutions they put into N2 were basically the developer correcting that initial mistake, optimizing margins and padding, implementing an auto layout feature.
And their future planned solution is key to understanding the compromise they landed on. They plan to add a config button that shows only the most common parameters on the node itself, and then pushes all the advanced stuff into a side panel or a dialog.
So they're balancing that original desire for visibility with the practical need for a usable workspace.
They realized maximum visibility was just the wrong trade-off from the start.
Okay, so now that the N2 architecture is solid, shifting from that object-oriented headache to a schema and immutability solution, we start to see the real potential of the modules they built on top.
Absolutely. The N2 Action Triggers module demonstrated real low-code capability. It lets developers quickly wrap existing Odoo model methods and just expose them as nodes on the canvas.
Minimizing the boilerplate.
A ton of it. Then the N2 Forecast module showed that even complex processes like statistical forecasting, which need scheduling and parameter tuning, they fit perfectly into this canvas model.
And the N2 AI module sounds like the most critical one.
For sure. It leveraged the new foundation to introduce these flexible REG nodes. That's retrieval augmented generation. This means a workflow can pull specific contextual data from any Odoo model and feed it straight into an AI prompt to get a structured response.
That's a huge leap forward for integrating AI with your actual internal business data.
It is. But all of this power, especially when you're mixing low-code visual pipelines with AI that has access to sensitive data, it leads to the single most critical safety lesson learned from the entire Nuido experiment.
The risk gets amplified.
Massively. Even though N2 workflows run under a specific user's context, meaning Odoo's own access control is supposed to govern what data the workflow can touch.
You can't guarantee the end user configured Odoo correctly.
There is zero guarantee. And the consequence of a flawed configuration is, well, it's catastrophic. A workflow could expose internal sensitive data financial records, HR data, to an external public-facing system, like a smart assistant or a public webhook. So the safeguards they put into N2 show that the developer really understood this responsibility. For the AI module specifically, the user now has to manually add and select the fields and models they want the AI to access.
So it prevents a misconfigured workflow from just accidentally exposing an entire database table to the AI.
Exactly. And what's fascinating here is that the project became this tangible lesson that applies way beyond Odoo. It's the realization that great power comes with great responsibility, and your low-code tool cannot assume a perfectly secure environment.
You have to build in safeguards even against your user's own mistakes.
We have to.
It's really a complete story arc. It goes from a simple aesthetic choice show, all the parameters, to this struggle with graph theory, the painful realization that the first architecture couldn't even support Odoo, and ultimately building a robust, safer system that can handle AI.
The N2 pivot proves that successful development often means admitting an architectural mistake and being willing to just replace the foundation.
That iterative process, the willingness to toss out that complex object-oriented N1 for a fundamentally sounder schema-based architecture in N2, that was the real win here.
It's a testament to valuing long-term maintainability over just the initial speed of development.
And as we wrap up, here's a final provocative thought for you to consider. The complexity of a dynamic user interface is often inversely related to the known size and intent of your user base. The new data developer had to pivot because they optimized for feature visibility without knowing who would use it or how. So if you were starting a new automation application today, how would you decide between optimizing for maximum information density or for the absolute minimal workspace complexity, knowing that the wrong trade-off could force you to rewrite your entire state management system down the road? Think about that next time you look at a complex visual tool.